Hello everyone, welcome to today's class. Before we look at what we are going to discuss today, I'll just have a quick recap on what we did the last time. In our last class, we talked about the hardness of water, and of course we looked at two types of hardness of water, which are the temporal hardness and the permanent hardness. And we also looked at ways in which we can remove this hardness from these types of water. And of course, extensively on the permanent hardness of water, we talked about 4 methods in removing the permanent hardness of water. One of it is distillation. The second is the addition of washing soda. The third is the addition of caustic soda. And the fourth one is the permutate method, which of course happens to be the complex of all other methods. Now, I also want to mention that the permutate method is applied in producing a large quantity of water. Anyways, today we want to look at the properties of water. And note, when we talk about the properties of water, we're simply going to be looking at the physical properties and the chemical properties. So let's start with the physical properties. One of it is that water is a universal solvent. Of course, we all are witness to it. When you look at water, you will agree with me that water is clear, is colorless, is odorless. Now, talking about the pure water and not waters from our sources like lakes and rainfall and all that. So the first physical property of water is pure water, is clear, colorless, odorless, and tasteless. The second property we want to look at is the boiling point of water. And the boiling point of water is simply 100 degrees Celsius. So it has a boiling point of 100 degrees Celsius. Now, the next property of pure water is that it has a freezing point of 0 degrees Celsius. The fourth property is that water has a maximum density of 1 grams per cubic centimeters at 4 degrees Celsius. Now remember that this property is what accounts for the anomalous expansion of water. Now the fifth one is that it is natural, or rather it is neutral to litmus. So these are the 5 properties, the five physical properties, I beg your pardon, of water that you can have. Now the next we are going to look at is the chemical properties. Thank you. I like that. Okay, before we look at the chemical properties of water, I'll quickly want to mention the electrochemical series. Note that the electrochemical series comprises of electropositive metals, and so this is just the outline of your electrochemical series, and so that will guide us in our chemical properties. So the first one is that we want to look at the reaction of water with metals. Now, when it comes to the first 3 I have there, if you look at my electrochemical series, you discover that I have a line in between the electropositive metals. Now, I want to take the first 3 of them as I. The first three are the highest in their electropositivity. And so for that case, if water is going to react with these metals, they will react with cold water to give us two products. The first product is going to be an alkali or an hydroxide of the metal, and the other product is going to be hydrogen. Now in this case, hydrogen is liberated. So here we're going to have KOH plus H2. So the next thing is that we have to balance our equation. So if we have to balance the equation, I have 2 hydrogen here. If I put 2 here, this will give me 2 of my oxygen, 2 of the hydrogen, and so on and so forth. I know you know how to balance equations, so I wouldn't waste time in doing that. The next is I want to take sodium. Sodium also behaves in the same manner as potassium. And so this will give us aqueous. If we balance the equation, then we are going to have something of that nature. Okay. Now, I'd like to note that these first 2 reactions are explosive ones. They are very explosive. So in other words, you don't have to carry out this kind of reaction in the house, right? And again, it evolutes a lot of heat, and this reaction is termed as exothermic. So please take note of that. Now, if we talk about calcium, calcium does the same thing. However, calcium is slow in its reaction. And so if it's going to react with water, it's going to only just be partially and not wholly as in the case of potassium and sodium. So we are going to have calcium hydroxide and hydrogen. This is aqueous, this is liquid, and that is solid. Okay, so if you balance the equation, you are going to have that equation. Now, the first 3, they all react with cold water. So they react with cold water. And the products formed again are alkali, and in the process, hydrogen is also liberated. Now let's get to the next set. If you look at magnesium, aluminum, and zinc, they have the same pattern of their reaction. Now, but in this case, they cannot react with cold water, but rather they will react with steam. So if they react with steam, what will happen is that the products that are formed are going to be oxides of the metal, and as well as hydrogen is given off in the system. So you have magnesium. In this case, water is a steam, right? Remember that water exists in 3 states as ice, liquid, and gas. So the gaseous state is considered as a steam. And so this gives us magnesium oxide, and you have your hydrogen produced. The same thing will happen with aluminium. Aluminium will give you, and we have this as L2O3, and this will liberate hydrogen gas as well. Okay, so here is going to be 2, and I have to put 3 here, and this will give me 3, and that is balanced. So if you do the same thing for zinc, zinc is also going to produce an oxide, and of course liberate hydrogen. Now in this case, reacts with steam. Now if you look at iron, iron is separated from the others. Now in the case of iron, the reaction of iron is that it's going to react with steam, but the steam is going to be in excess. It's not just going to be limited as in the case of magnesium, aluminum, and zinc. And so in this case, zinc is in excess. So you have a reaction, reacts with excess steam. So if I'm going to write that equation of reaction, it's going to be thought and this will give us the oxide So if you look at all of them, of course, they react with steam, while iron reacts with excess steam to give us its oxide, and as well as, of course, in the process, hydrogen is liberated. Okay, so let's move over to the third phase. The third of them is that if you take, okay, so if we look at the next one, tin, lead, copper, etc., just as you have it in your ECS, these ones, they have no reaction with water. No reaction with water. Okay, so I am going to continue, but it's going to be in our next video coming up soon. Stay tuned and watch out.